Hi, this is Leah, and this is week 1, and this is my interactive advanced concept presentation. The focus is on gummy bears. So some key concepts that relate to this week and this experiment are colligative properties, which these are the properties of a solution that depend on the ratio of the number of solute particles to the number of solvent molecules. So 4 properties are vapor pressure lowering, boiling point elevation, freezing point depression, which was what our week 1 lab focused on, and osmotic pressure, which is what this presentation will mostly focus on out of these properties. So osmotic pressure is a pressure that occurs when 2 solutions of differing concentrations are separated by a permeable membrane. So, and we'll dive into this later, but in this example, it would be the solution of water or salt water that's being separated by the gelatin of the gummy bear, and then the second solution would be the particles that make up the gummy bear. That's not the gelatin, which acts as that permeable membrane. And then another key concept is osmosis. So this is the spontaneous net movement of particles from a higher concentration to a lower concentration, which, as we've just talked about, obviously ties into the osmotic pressure. So osmosis is just that actual movement of the particles from one area to the other. So this experiment, we needed a couple things. So you needed tap water, vessels to hold the tap water. I just used paper bowls, gummy bears, and then salt. So what we wanted to do was place one gummy bear in a vessel of just regular tap water, and then place the other one in saturated salt water. So I poured water into the bowl and I stirred in salt until I saw it start to precipitate and it would not dissolve anymore. Then I let these sit for 6 to 10 hours. I let mine sit for 6 hours, and then I observed what happened afterwards. So what did we see? This red gummy bear was the one that was in just regular tap water. So the one on the left here, this was not put in any water. This is just a comparison. And this was the gummy bear after it was sitting in the tap water for 6 hours. So we can see that the gummy bear that was in the tap water is slightly larger than the gummy bear that was not sitting in the tap water for 6 hours. It's not a huge difference, but it is definitely larger vertically and horizontally. So you could tell that it absorbed some water there. And we're going to talk about why in a second. So now let's go on to the saturated saltwater gummy. So this one on the left is just a comparison again. And this one on the right was the gummy bear that was actually sitting in the salt water. And they look pretty much the same size, so vertically or horizontally. They seem to have not changed too much, so it doesn't seem like it swelled and absorbed any water. So why did this happen? So this is where our key concepts tie back in. So this is due to osmotic pressure and osmosis in regards to the red gummy bear. So the red gummy bear, which was just in regular tap water, the tap water didn't have any salt in it, but the gummy bear still had salt and particles inside of it. So the gummy bear concentration of salt was higher than the water concentration of salt. So the water, through that osmosis and that osmotic pressure, that force being put on it, wanted the water to move into the gummy bear so that they can be in an equilibrium with each other. But with the green gummy bear, that didn't happen. The water did not go in. And this is because the green gummy bear was sitting in a hypertonic solution. So the salt water surrounding the green gummy bear is the hypertonic solution. So that means that the salt concentration was higher in the water than in the gummy bear. So since the salt was higher in the water didn't want to leave and go into the gummy bear. It wanted to stay where the high salt was so that it could try to be at equilibrium as much as it could. Alright, thank you for listening. Have a good week.